All right. So, containerized control systems. We have a lot of goals for this session. I'm going to kind of try to jump right in here because we do have pretty short time. But first I want to say I had a couple of polls leading up to this, and I was a little bit surprised about the results. So 25% thereabouts of respondents said they're already using a containerized control system. But the vast majority of respondents said they're a beginner in containerized technology. So if you're wondering about the relevance of this session, I think those numbers kind of speak for themselves right there. What we're going to try to do here, our goals, is really cover what the benefits and the cons and that of containerized control systems are, how vendors are in either better or worse conditions to support owner and operators, and if they can be less transparent about what they're giving. Is containerized control systems the new black box, right? And if effective methods really exist for monitoring the security and controlling what we see in those containerized systems. At the end of this, my goal is that owner and operator should be able to look at this and go, well, should they embrace or should they resist containerized ICS? So what does a containerized control system look like? We still have the traditional field devices, your PLCs, your intelligent devices. They're all still out there. The big difference is in the data center, at the SCADA level systems. So in the containerized system, we have a cluster. The cluster contains all of these different components. So no longer are we on the traditional bare metal. We're not even really on the VMs. We exist in this kind of hyper-converged infrastructure that has a cluster of a whole bunch of containers that can be created and destroyed in an instant based on what our needs are. Those containers can contain things like operator interfaces, the SCADA-based system, your protocol gateways, all of your logging systems, your databases, service buses for communication between all of those different components. Your security components can be in there. And then there's things like sidecars, which we might get into a little bit if we have time. So our operational concerns. The nature of containers is that they're disposable. They are created essentially to be destroyed. They can be created on demand. They can be destroyed on demand. They can crash and be replaced with a new clone very quickly. But that disposable nature is not necessarily compatible with the mission-critical systems that we have in a SCADA-type system or any ICS control system. So these systems, containerized systems, were originally designed for availability over reliability. In our world, reliability really matters. So we have to make sure that we implement control systems in a way that are highly reliable. So this can be done with containerized technology, but it's very important that it be done right. One of the biggest challenges that we see that I'm going to talk about again and again and again throughout this presentation is the continuity of containers data. So if you have containers that are coming into existence and going out of existence, what happens to the data in the phase in between? Is there appropriate overlap? Does that data get transferred correctly, or does it get lost? One of the last big challenges is the increased complexity of this architecture. I mean, this is leagues ahead of something like bare metal-based SCADA systems. So being able to manage and maintain them is very fundamental. It's key. Impacts of these concerns. So that typical container lifespan could be seconds, minutes, hours. It's not generally days, weeks, years. That being said, containers can persist for pretty long periods of time, but it's not necessarily their design. The persistence of data, again, I'm going to harp on this over and over again, is really important between that container end of life and the reincarnation. Generally speaking, if a new container is stood up before the other container dies, there's a moment of time in which you can transfer data, ensure that there's a nice, smooth handoff of power. But if a container crashes and a new one has to be spun up to take its place, how do you ensure that no data is lost in between that process? And that comes down to persistent databases. Your data can't be handled by the individual containers. They have to be handled by specialized databases that have persistent data, and all of the containers can reach out to that to get the information they need. You need centralized oversight. Orchestration is very key in a containerized space. Inside of the container, they create their own virtual networks that are changing constantly. As the containers change and move and shift around, the network is rebuilt and redesigned constantly. Without good orchestration, those networks can become incredibly messy and can lead to dropped packets. Now, we're only talking a few packets here, not massive amounts of data. And in the IT world, we see that sometimes they just don't care. Data gets retransmitted, it's no big deal. As everyone in this room knows, in ICS, that can be a critical impact if we start to lose data, even just a few packets here and there. So we have to have really good orchestration in the containers, in the clusters, to ensure that we don't have messy networks that lead to dropped packets. Last big impact, because of that complexity, you need to have personnel that have the skill and knowledge required to be able to maintain and support these and do the monitoring appropriately. You're going to find a lot of folks out there that are familiar with containers. They're not new technology. They're new-ish, but they're used widely. It's all over the place. But you're not going to find a lot of people that have ICS specialized knowledge and also container specialized knowledge. It's a relatively rare breed, although it is growing. So the operational benefits, the cool stuff. Probably one of the single biggest benefits, and one of the main reasons that we are seeing a move in this direction that's being supported by owner-operators, not just by vendors, is that you can have rolling updates. So you can have security patching to a live system without downtime. So it's no longer that take your plant offline once a year and do all of your security updates, all of your software updates, and any of your feature enhancements. They can now be rolled to a live system. It is critical when you're doing this to be able to test it. So one of the things that you must have if you're going to switch to a containerized control system is a test bed, a replica of your production system that allows you to test all of your security patches, all of your updates, all of your feature enhancements before rolling them into your production system. But if you do the testing appropriately, you can roll any update into a live system without downtime. Huge benefit. SCADA changes can also be rolled into live environments, but that is a whole different talk. It is incredibly complicated, and I would not recommend it for any novice. So all those people that said they're beginners in container technology on the poll, you don't want to roll SCADA changes into a live system. You want to make sure you know what you're doing first. It can be messy. Another huge benefit, and one of the other main reasons we're seeing vendors move towards this is, not just vendors, sorry, owner-operators moving towards this is the dynamic scalability. So if you have a very static manufacturing facility, let's say potatoes in, chips out, recipe management system in there, a few machines, this isn't really a benefit for you. And in fact, containerized control systems are probably not the appropriate way for you to go. This is really more geared towards systems we see where they have changing demand. So where I come from in the energy utility industry, we're seeing a huge move towards this in the distributed energy resources. You have tons of devices all over the place, some of them small, some of them large, connecting to utilities at varying rates. And they come either through aggregators or through direct connects, depending on their size, but it can change day to day, and it scales up over time. So dynamic scalability gives us a huge advantage in this. We have the ability to grow our system on demand. More people want to connect, all right. We spin up new containers. We have replicas of the same container, right? We can have as many as we need up to our hardware limitations to match the demand on demand for each given connection. And as those connections die off for whatever reason, we can scale back down, dedicate hardware resources to other needs. So when we're managing our own data centers, this is a huge advantage. This is probably the #1 reason that we are seeing this movement in the electrical utility industry, is because those of us in the utilities that are being forced towards the distributed energy resource management systems, this is huge. This is our main benefit. So DevOps, this was talked about a little bit earlier today. I was actually glad this was brought up. We are seeing a movement, and certainly within the container space, this is almost exclusively the agile development method is followed. And in this, we will see more iterative designs. So instead of the very traditional sense where you buy the package, you get the package, you test the package, you install it, and you leave it alone for 10 years, we're not seeing that anymore. Now it's, you get this little piece, and you test it, and you install it, and you get a new little piece, and you test it, and you install it, and so on and so forth. This has some benefits. Certainly, we've seen improvements in reliability with the agile development method. You don't have to wait years for your bug fixes anymore. They can be deployed in weeks or months. Security updates can come a lot faster, so there are definitely benefits here. The continuous development cycle does have drawbacks, though, that we will get into here in just a second. But you also get the regular feature drops, right? So huge benefit for both the vendor and for the owner-operator. If an owner-operator wants a new feature, they can request it, and the vendors usually have a method by which to get it into the next iteration, and you can quickly have that. Iterative design. All right, so the benefits of this vendor support method. So the small and continuous updates can be deployed to a live system. I've talked about this a couple of times, but this is huge in a lot of senses because no longer are you stuck with the control system you bought until you buy a new one. You can have continuous updates either through software, security patches, or features that can be added at any point in time to your product. And the feature requests are now no longer a major update. You can go to your vendor and say, hey, I need this feature. And they can build it either into the system as it is, or they can actually build it as effectively a bolt-on, a new container, because the cluster can host any number of containers. And if they add a new container to that, and they update the orchestration, they update the communications bus, they can have all of that merged together and bolt in a new feature to your SCADA system effectively on demand. And instead of talking about possibly years to get new features, some vendors could turn that around in months, maybe even less. There is also lower development costs incurred by the vendors typically, not universally, with this technology. And from what I've seen, that does seem to translate into more features and functions that are available to owner and operators. I'd say that it translates into lower costs for owners and operators, but I have not seen that yet. It is highly vendor dependent. Some vendors are very much into this technology. Some are just looking at it now, and some have never looked at it. So there's a lot of variation there. Now the other side of this, the Agile testing method is an involved process. Like I said earlier, it's not just buy the thing, test the thing, deploy the thing, forget about the thing. It's constant testing. You have to have a test bed. You have to be testing every update. You have to be testing every software patch, every new feature. They have to be tested and then deployed, tested and then deployed, and over and over and over. So you have an endless testing process, which is a huge change, a very big shift from what we're traditionally used to, and that's something that has to be planned for. Most of these, in fact, everyone that I've seen, every containerized control system has a significant amount of open source or third-party technologies in it. Not necessarily a bad thing. It does add some challenges, though. Because there's so many different components that are all integrated together to make these, management of it becomes complicated. You have to have good monitoring systems to be able to look at what's in the container and appropriately adjust and control your updates to ensure that all of that open source software, which could be hundreds of different packages, is all up to date, has all of its vulnerabilities and security patching deployed, and that can be a challenge, but there is software to help with that, which we'll talk about here in just a bit. The challenge that comes with that is a large number of software update sources. Ideally, your vendor should be providing you all the updates for every open source piece of package that they've delivered in their product. But the reality is, if you want to verify that, you have to go out to the different sources of this open source software and check for that. Again, there's packages that help you manage that, but it is something to think about. So this makes your steady state look a lot different. And change management really becomes your friend when change is constant. It's really important to be able to manage those changes, know where you are, know where you're going. So if you're looking at constant change, change management is key. So what can hide inside of clusters? From the outside world, clusters do kind of look like a black box. And it's important to have lots of visibility into them. First step on that is good contracts. You have to have stringent cybersecurity requirements in your contracts, and I cannot emphasize this enough. You need to have software bills of material. You need to know what you're getting delivered because of all that open source, because of the third-party applications that can be contained in these and are contained in these. It's highly important to get software bills of material. I know we're kind of new to talking about that in this industry, but it is fundamental. You should not proceed without a good software bill of material. Visibility to those internals, like I said, externally from the cluster, they look a little bit like a black box. Things go in, things come out, but what happens inside from the outside view is a little unclear. So it's really important to have something inside of these clusters that provide you with visibility to what's going on. Vulnerability management, huge, huge here. You got to look at all of the software that's in there, keep track of all of it, and have specialized container vulnerability management systems that can see inside the container, see what's installed, and respond appropriately to vulnerabilities when they're discovered. So security solutions and practices. There is specialized software available for containers that provide discovery, monitoring, and protection. They are not like your typical systems that you see outside the container world, although they serve the same functions. They are installed within the container. I'm not here to plug any one vendor. There's actually quite a few of them out there, and they're all very good. They all have their pluses and minuses, but it depends on how you're using them. Some of those things that they can do that's really key is they do provide log capture from inside the cluster and deliver that to your SIEM outside of the cluster. And that is huge, right? Because you want to have that visibility into the cluster itself. Active enforcement is another big component. I know active enforcement is not necessarily always smiled upon in our industry, but I think that while network active enforcement may be turned off, it's important to have protection against things like rogue containers. A rogue container can be a container that's been compromised and is now doing something it's not supposed to be doing, or a container that's not even supposed to be there to begin with. Signed container images is another thing enforced by these security tools that goes right to that. This is also really important. If you can work with a vendor and they can sign their images with a certificate, the security tools will not allow a container to come into the cluster unless it's cloned from a signed image. Huge protection there. I can't speak to that one enough. That is very key. In credential management, what this allows is that you can have identity providers that are outside the cluster managing the credentials inside the cluster. You'll see a lot of delivered clusters that have default credentials built into them because, that's how the vendors run it. They don't have an identity management system like the owner-operator does. So the security solutions allow you to integrate your existing identity management system into the clusters and all of the internal credentials which are contained in them. Inside the container, credentials are slightly different than outside, but the security tools help integrate them, so they're really not. And contrary to what some vendors might tell you, not everything needs to run as root. Typically, everything will be delivered in the containers, all applications running as root, and that can usually be restricted to some level. It helps prevent things like rogue containers because it's a lot harder to compromise the application to then compromise the container that contains that application. The security tools that are out there today are not ICS specific. That's important, but it's not necessarily critical. I have heard that there is movement towards that direction from some of the vendors, and there may even be some I'm not aware of, but to my knowledge, there are none that are ICS specific yet, and we'll see when we get there. All right, so should you embrace or resist containerized ICS? This is really the goal here, and we had a pretty short period of time, so I'm hoping we can get most folks there, but it's highly dependent on your organization. Again, if you're doing potatoes in, chips out, this probably isn't the right technology for you. If you're really struggling with virtualization and you don't want to go that way, if you're not looking at already doing hyper-converged infrastructure, then you probably don't want to make the leap to containerization. If you go straight from bare metal to containerization, it's going to be a painful move, and I would strongly advise against it. But to each their own. So then you have to really ask yourself if you have the will, desire, and the personnel to support it. Again, as I mentioned earlier, this does take specialized personnel to maintain, to monitor, to manage. If you don't have the people with the skill set, it's important to have them first before you move to a containerized system. So if you're looking at vendors that have a containerized solution and thinking about going that way, if you're part of that 25% that said, yes, you have one, and also part of that percent that said, what is a container? It's very key to make sure you have the personnel. So training is important here. You can take your ICS people and you can train them in container technology. It's not some super crazy out there technology that no one's familiar with. There's lots of information available, even just free online. But it's important to have the people who are willing to support it and have the skills and knowledge to do so. The other thing is, do you already have your own redundant data center or a desire to build one? Containerized control systems are not something that lend themselves to being ran on a single server on a rack somewhere in a closet that never really gets touched. They run on racks and racks and racks of servers in data centers. If you really want to have a good system, they need to be redundant data centers. Container technology does lend itself to redundancy quite well because you can replace containers on a whim. So if you have redundant data centers or a desire to build one, it might be the right way for you. And really, as the individual organization, you need to ask yourself if those benefits really outweigh the risks, right? So is scalability hugely important to you? If you don't scale, then there's really no need for containerized solutions unless the other benefit of live updates is what matters. The live updates is a huge benefit. I mean, I don't want to beat around that. Being able to roll security patches to a system without downtime is a game changer for this industry. And if we see things continue to move in that direction, then us as security professionals in the ICS world don't have to worry about those patches that are a year old that we haven't deployed yet, because we'll be able to put them into a production system without downtime. That is a huge, huge benefit, and one of the main drivers, I think, in the acceptance of this technology. So, with that, any questions?
Hey, Brian, I really appreciated your talk. In your opening architecture slide, it looked like you, it looked like you were putting PLCs to the side of the containerization part. And you also mentioned be really careful about trying to do SCADA with containers. So I just wondered, what are the sort of like first use cases that you think make sense for containerization in ICS? Like doing what to solve what problem?
Yeah, so the stuff we're already seeing today. The SCADA system itself can be contained in containers, but typically we don't see the physical I/O in there. Virtual I/O, that's a different conversation I've had with some folks, and we'll see where that goes. But some of the first use cases we're seeing, at least in my experience, are in the electric utility industry because we have such scalability needs for our control systems. So we're seeing those distributed energy resource management systems, DERMS as we call them, appear in that because they're largely scalable, and that's our huge benefit. But I think we're going to see more and more. I have talked to a few vendors outside of that industry that are moving towards this, largely because it's easy for them to develop new products and because of those rolling updates. So I think we're going to continue to see the movement towards that direction.
Can I ask a follow-up question?
Go for it.
Is there anybody else? So my follow-up question is like, is it data aggregation? Is it data exfiltration? Is it user interface stuff? Is it analytics? Like, what are the things people are doing specifically?
Sure, yeah. So yes, all of that. Again, this is relatively new technology. I was actually a little surprised that 25% of the respondents to the poll said they're already using a containerized ICS. I knew they were out there. I'm involved in some of them. That was a bigger response than I expected, though. But yeah, we're seeing a lot of that deployed already. The traditional uses of containers, right, are more in the IT data centers, hosting huge web applications, that kind of stuff. In the control world, we're starting to see the movement of these systems into containers largely to support that. And I think I've wandered off your question a little bit, so I apologize about that. Yeah.
Thanks a lot.
Yeah, absolutely.
You mentioned that the container security software isn't necessarily ICS specific yet. What changes to those systems do you think they would need to make them ICS specific?
Yeah, absolutely. Great question. So a lot of it's going to be protocol support, right? So one of the things that these solutions provide is your ability to monitor network traffic, very similar to what we see outside of a container. But a lot of them don't have ICS-specific protocols supported yet, and I think that's probably one of the biggest needs for those internal container security monitoring tools in the ICS world is to support ICS-specific protocols.
Thank you.
Mm-hmm.
So other side, sorry.
Yeah, no, it's good.
You asked a question, or you referenced a little bit about hypervisors. Do you see hypervisors as being a step towards containers, or do you see a straight jump to containers in some of the ICS space?
Yeah, so I have seen people jump from bare metal straight to the container world, and I would, like I said earlier, I wouldn't recommend it. Certainly, an understanding of virtualization is beneficial to containerization. The technology is similar. It's kind of the next evolution of virtualization. Yeah. So a good, solid understanding of virtualization is going to be important in monitoring and managing a containerized system.
And then one follow-up, you mentioned testing as being critical. So one of the things we've been looking at in labs is virtualizing using hypervisors for substations. If you start getting into the size of a test environment that you need, do you see a test environment being a representative of the various types of substations, the small, intermediate, 230s, whatever it might be? Or do you see a test environment needing to be an exact virtual representation of the entire SCADA system?
Yeah. So it does not need to be exact, but it should be very representative of. Certainly probably scaled down for the test environment. Trying to manage a test bed that's the exact same size as a production system could get unwieldy. So yeah, a scaled down version would be really good.
Hey, Brian. Good talk. I just had a question. It was intriguing, the live updates and patches to systems and large thermal plants come to mind. You know that, hey, you got to wait until next spring before we do anything.
Yeah.
Have you seen any adoption of containerized security around those types of large, I'll call them legacy systems?
Yes. So yeah, I'm very aware of some adoption to legacy systems I can't directly talk about, but yeah, it's out there. Certainly there's some resistance to it though, and I think appropriately so. People are, again, back to personnel. If you don't have the people to support it, it can be a very dangerous thing to do. So yeah, there is some movement towards these legacy systems being containerized, but I would say it's much less than we're seeing the management systems being containerized.
Great, thanks.
Yeah.
I guess I have the last one.
All right.
So I'll ask you to predict the future in that. So we've done the work that we've done on containers has been for functionality, but then also as a protocol adapter type stuff, in that you can hide the south side device that speaks DNP3 Modbus so that you can move on to a newer world, right? So what do you think it's going to take in the future to have a lot of what happens in the gateway world that sits on top of these edge devices is we're trying to showcase what the future would look like when some of these principles are adopted and get to the edge. What do you think it's going to take for a protection relay, basically, to run some lightweight version of containerization? It doesn't have to do a lot, but at least it brings it into the world where you can update it, So.
Yeah, so I like where your head's at. I think it's cool, from a sense of like, oh, this is super neat, cutting edge technology. I do think we're pretty far away from that. Maybe not necessarily far away from vendors wanting to do it, but pretty far away from owners and operators wanting to adopt it. I've for years in this industry heard talk of virtualized relays, and I know of very few people who have adopted virtualized relays. So going to relays that have containers on them, we're probably pretty far away from it. But I would say there's certainly some benefits. Again, that scalability might really serve key there. But yeah, I don't think we're not there today, certainly, and I don't think we're going to be there in the near future, but perhaps the far future. All right, thank you, everyone.